Hello everyone, welcome back to my YouTube channel, The Maths Hub. So today in this video, I'm going to start a new chapter. Name is Limits and Derivatives. So first we are going to learn what the limit is, and secondly we are going to start derivatives. So without any further delay, let's get started. First, let us know how we can write limits. It is written as limit x tends to a, f of x is equals to, let's say it is k. Now, x tends to a. X is not equals to a. Tends to a. This f of x is a function. F of x is a function. And this k is the answer. And this k depends on the value of a. We will substitute the value of a in the function of x and we will get the answer. Now let us suppose limit x tends to 0, f of x is equals to what? Let f of x be any function. Now let us suppose that this function is sin x. F of x is equals to sin x. Now substituting x is equals to 0, sin 0 is 0. So answer will be 0. Remember that it tends to 0, it is not equals to 0. Now limits are generally of two types, are divided into two types. What are they? First one is left hand limit. Second one is right hand limit. Okay. So our left hand limit is, this is our axis, x-axis and y-axis. Now let us suppose a function f of x. Now let us take one example. Let it be 1 when x is less than or equals to 0, and let it be 2 when x is greater than 0. Done. Now let us substitute this in this graph. X is 1. It is 1. It is 2. Okay, this is 0, 1 and it is 0, 2. So first one will be like this and second one will be like this. X greater than 0, it is 2. Value is 2. Now this x is less than or equal to 0. This part is called as left hand limit, and this part will be called as right hand limit. Now how can we write left hand and right hand limit? We can write it as limit x tends to 0 minus. Why 0 minus? Since x is less than or equal to 0. X is less than 0. So x tends to 0 minus f of x is equals to 1. Limit x tends to 0 minus f of x is equals to 1. And the right hand limit can be written as x tends to 0 plus f of x is equals to 2. Done. Now let us see some theorems of limits. our first theorem is, if there is a sum of two limits, for example, limit x tends to a, f of x plus g of x, it is written as limit x tends to a, f of x plus limit x tends to a, g of x. Number 2, if there is minus, how it will be written as limit x tends to a, f of x minus limit x tends to a, g of x. For minus, it is also same. Third rule is limit x tends to a, f of x into g of x, product. It will be written as limit x tends to a, f of x into limit x tends to a, g of x. Third rule will be division. In case of division, it will be just, we will divide both the limits, limit x tends to a, f of x by g of x, f of x by g of x. Fourth rule is limit x tends to a, lambda into f of x. Where lambda is constant. Now we will just simply take out this constant. It will be limit lambda into limit x tends to a, f of x. So these are the 5 theorems used in limits. Let us solve one example. Limit x tends to 1, x cube minus x square plus 1. Now let us use the first theorem. Limit x tends to 1, x cube minus, it is our second theorem, x tends to 1, x square plus x tends to 1, 1. Now x tends to 1. So substitute it here, x cube minus 1 cube minus 1 square plus 1. 1 minus 1 plus 1, it is 1. Let us solve one another example. Limit x tends to 2, x cube minus 4x square plus 4x by x square minus 4. Now don't take it as limit of this by limit of this. Let us solve it in some another way. Limit x tends to 2. Now this upper part, if we take x common from all the terms, it will be x square minus 4x plus 4 by x square minus 4 can be written as 2 square. It will be limit x tends to 2, x into, this is in the form of a minus b whole square. So what it will be, x minus 2 whole square by, this is a square minus b square. So it will be a plus b, a minus b. Now let us cancel one term, x minus 2 and this x minus 2. It will be limit x tends to 2, x into x minus 2 by x plus 2. Now substitute x as 2. It will be 2 plus 2, 2 minus 2 is 0, 0 by 4 is 0. Theorem number 2 is limit x tends to a, x power n minus a power n by x minus a is equals to n into a power n minus 1. n, x power n minus a power n by x minus a is equals to n into a power n minus 1. X tends to a. There is a proof of this theorem which I will be sharing in another video. So first let us solve one example on this theorem. Let us take one example. Limit x tends to 1, x to the power of 15 minus 1 by x to the power of 10 minus 1. Now it is in the form of x power n minus a power n. Now 1 power something is equals to 1 only. So there is no need to write it as a power n. Let us assume it to be power 15 and power 10. Now see, it is not in the powers are not same on both the denominator and numerator. So we have to write it as limit x tends to 1, x to the power of 15 minus 1 to the power of 15 by x minus 1 by x to the power of 10 minus 1 to the power of 10 by x minus 1. Now if you cancel, see here, if you cancel x minus 1 and x minus 1 of both the numerator and denominator, you are going to get the same term as before. So now by theorem number 4, which we have studied just a few minutes before, from there you can see that it is the rule for the division. So in division rule, limit x tends to 1, we are going to write it as x to the power of 15 by 1 minus 1 to the power of 15 by x minus 1 divided by limit x tends to 1, x to the power of 10 minus 1 to the power of 10 by x minus 1. Now substitute. What is the formula? N into a power n minus 1. Here n is 15 into a power, a is 1, a power n minus 1. Similarly on the denominator, it will be 10 into 1 to the power of 10 minus 1. So its answer will be 15 by 10, 3 by 2. So this was all for this video. In the next video, we are going to learn another 2 theorems in limits, and we are going to solve our first exercise in the limits and derivatives chapter. Thank you. Bye bye. Please do subscribe my channel. If you like this video, please do give a like. Thank you.